Welcome to this tutorial on standard deviation with NumPy's std function. Standard deviation is a fundamental statistical measure that helps us understand how spread out our data is. In this video, we'll explore how to use NumPy's std function to calculate standard deviation efficiently. Standard deviation is a measure of how spread out the values in a dataset are from the mean. In other words, it tells us how much individual data points typically differ from the average value. The formula shown is sigma equals the square root of the sum of x minus mu squared, divided by n here. Sigma represents standard deviation, x is each individual value, mu is the mean, and n is the total number of values. A low standard deviation means data points are close to the mean, while a high standard deviation means they're more spread out. The basic syntax for calculating standard deviation in NumPy is simple. First, import NumPy as np. Then, call np.std and pass your array as an argument. The function returns the standard deviation of all elements in the array. This is the most straightforward way to calculate standard deviation for your data. Let's look at a practical example. We create a NumPy array called data with the values 2, 4, 4, 4, 5, 5, 7, and 9. Then we calculate the standard deviation by calling np.std on this array and store the result in std_dev. When we print the result, we get 2.0. This means that on average, the values in our dataset deviate from the mean by about 2 units. For multidimensional arrays, you can calculate standard deviation along a specific axis. Here we have a 3 by 3 matrix. By setting axis equals 0, we calculate the standard deviation along columns, which gives us one standard deviation value for each column. By setting axis equals 1, we calculate along rows, giving us one standard deviation value for each row. This is particularly useful when working with datasets, where rows might represent different samples and columns represent different features. There are 2 types of standard deviation, population and sample. The key difference is in how they're calculated. Population standard deviation, which is the default in NumPy with ddof equals 0, divides by n, the total number of values. Sample standard deviation, specified with ddof equals 1, divides by n minus 1. Use population standard deviation when you have data for an entire population. Use sample standard deviation when you're working with a sample from a larger population, as it provides an unbiased estimate. Let's see the difference in practice. We create an array with 7 values. When we calculate pop_std without any additional parameters, we get the population standard deviation, which is approximately 4.899. When we calculate sample_std with ddof equals 1, we get the sample standard deviation, which is approximately 5.237. Notice that the sample standard deviation is slightly larger. This adjustment compensates for the fact that we're estimating from a sample rather than having the complete population. Let's recap the key points. First, np.std measures how spread out your data is from the mean. Second, use the axis parameter when working with multidimensional arrays to specify whether you want standard deviation along rows or columns. Third, the default calculation uses the population formula with ddof equals 0. And finally, set ddof equals 1 when you need the sample standard deviation. Understanding these concepts will help you analyze the variability in your data effectively. Thanks for watching.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.